Again, even though I'm recording, guys, if you have questions, please ask the question so that everybody can benefit. All right, so this is going to be writing. Is that showing up? Good. Writing names of compounds from formulas part 1. Okay? All right, so we will be using the flow chart. For those of you doing this at home, I will post both the PowerPoint version and the paper version, but you will get one. It will be on blue paper, and you'll be allowed to use it on the test, okay? So this is our flow chart. Okay, we'll come back to that in a second. All right, in order to do this, we need example problems. So we're going to start with this one. Okay, MG, hold on, let's go MG3, N2. MG3, N2. All right, so this will be our first practice problem, or our first example. All right, so we are going to start where it says start, and you come down here. So does this formula start with hydrogen? No, it does not. All right, so we go down to the next question. Oops, let me slide it up. I know it's a little tough to read on the video, but if you printed off the flow chart, you should be able to do it from there. Is this first part a positive ion, in parentheses, a metal? Okay, so the first element is magnesium. Is that a metal? Yeah, it's over there in the second column. Remember, on the periodic table, anything below and to the left of the staircase is a metal. Okay, so it's definitely a metal. So we go over this way. Yes. All right. Oops. Let me get it up here. We're going over here to the yes. And is the charge known? Yeah. So magnesium, you say yes. And it is, because it's in the second column. Magnesium has a charge of what? +2, positive 2. All right. So since the charge is known, all right, then we just write the name of the positive ion. So we're going to write magnesium. Is spelling important? Yes. On the test, if you spell it wrong, are you going to lose points? Yes. Do I let you use a periodic table that has the correct spelling on it? Yes. Is there an excuse for not spelling it correctly? Okay. In that case, I know those people and I work with them. So yes, I do have stuff like that. Yeah, that is a little bit different, but for the most part, no. All right, so magnesium. Now, we follow, after we do the process in this box, we go over here and, after we do the process in this box, we go over here. Is the negative ion mono or polyatomic? Okay, so mono means it's one element. You may have more than one of that element, but it's just one element. Poly would be multiple elements, and so it would come off of the polyatomic ion sheet. All right? So, N2, is that mono or polyatomic? Mono, it's just nitrogen. All right? So, we go up here to mono. We're going to write the name of the element, but change the ending to IDE, the suffix, if you will. So nitrogen would be what? What? We're going to change to IDE. Nitride. Nitride, yeah. Not nitrate. Nitrate's one of our polyatomic ions. So nitride. Okay. Now, if you notice, and I'm trying to be really good about this, I lowercase both of these. I did not capitalize either one. Technically, unless it is a brand name, they should be in lowercase. All right? We ran into a situation with a couple people on their college test this year that the professor on campus took off a half a point because they capitalized where they shouldn't be capitalized. I've never actually ran into that until this year. Kind of over the top, I think, but for now, you know, there you go. So I will not be taking off if you capitalize, just so you know. All right? but be aware. All right. Hey, and I am seeing people on computers that maybe need to not be on computers, need to be paying attention. I'm just going to throw that out there. All right. You guys ready to do another one?
Yeah.
Yes. All right. I got to remember what my second example was. What did I do with them? Ah. Did I throw them away? No. What did I do with them? All right, hold on. I gotta take you. Okay, we are going to use. Oh, I know what it is. All right, so we're gonna do this one. MOO2. Now, do you guys see why capitalization in the formulas is super important? Yeah, I hope so, because it is. All right, very, very important. Here we go. Okay, there's where they are. They're underneath here. All right, MOO2. Okay, so let's go through our flow chart. All right. Does it begin with hydrogen?
No.
No. Is the first part a positive ion / a metal?
We don't. It's not in the column.
It's not in the column, but is it left or below the staircase?
Yes.
Yes. So it's in the middle, which is a transition what? Transition metal. So if it's a metal, it will be positive. So yes. All right. Do we know its actual charge?
No.
No. Okay. Now, real quick, in case you do use the PowerPoint version, the technical name for a charge is oxidation number. So it'll say, do you know the oxidation number? All right. Oxidation number didn't fit in my little box on the flow chart, so that's why I just made a chart. All right. So we do not know the charge. So then it says we must calculate the charge of the positive ion. All right, so we're going to do a little bit of basic algebra. Remember when you did algebra and you were like, when am I ever going to need to know this? The answer is now. All right. Okay, first of all, if there's no number here after the MO, what number is actually there? 1. Okay, so we're going to steal that 1 and we're going to put it right here. Okay, so there's a 1. We don't know the charge. In algebra, what do you put for things you don't know? What kind of variable? What's the most common one? X, there you go. Could you put Y or Z or whatever you want to put there? Yeah, I don't care. All right, the X stands for the unknown charge or unknown oxidation number. All right? So that's what we're going to be solving for. All right. Okay. Plus, how many of the second element is there? 2. All right. Do I know the charge of oxygen?
That's my idea.
-2. All right. So that is where we put the known charge. And we are always going to know the charge of the negatives for what we're doing. All right? And then we're going to set the whole thing. What's the entire compound got to come out to equal? 0. Okay, side note, if we were trying to figure this out for like a polyatomic ion, then you would set it equal to the polyatomic ion's charge. All right? Now we just do our algebra like normal. 1x is the same thing as what? X. Plus, what's 2 times -2? -4, so we could just say x minus 4 if we wanted to. And we're going to still say it's 0. How do I get x by itself?
You would subtract x.
Yeah, well, I could subtract x, but then I'd get a -x. Or I could add 4. So I add 4 to both sides, and I get x equals 4. All right? Once we have the charge, after we calculate it, then we're going to write the name of the positive ion with a Roman numeral for its charge in parentheses. So, what's the Roman numeral for 4? IV. So we write MO. MO is molybdenum. So, or molybdenum. That's how I remember how to spell it. But you'll be able to look it up. Oh, should be lowercase, my bad. All right, then parentheses, IV. Okay, and then we go on to the second part of our flow chart. Okay, is the negative ion mono or polyatomic? Mono, it's just oxygen, right? Okay, and so how do we write the name of oxygen? Oxide, very good. So the way I would say this would be molybdenum 4 oxide. Yeah, molybdenum. I think it's used as an element that's added to steel to give certain qualities. I think makes it harder and more rust resistant. I believe. I don't know. All right, let's do another one, shall we?
Wait,
Sure.
really? You want to? Yeah. Still in my No, I look my own back. No, I don't think so. Pretty sure that was mine.
I think my screen on my computer's messed up. I don't know. Maybe not. All right. You guys ready now to do another one?
One sec.
One sec. Did you not write anything down while I was doing it?
Well,
I don't think he was paying
really wish
attention.
I had a pencil.
Yeah, I don't think he was paying attention. He was goofing off.
So I would
So you
say
had two pencils?
No, I took my pencil.
Actually,
I
that was
took my
mine.
pencil.
Okay.
I borrowed a pencil.
If you need a writing utensil in the future,
Okay,
I've got plenty.
Alright.
All right.
Steal both my pencils.
All right. Are we good now, Noah?
That's mine.
No,
Let's
let's-
go.
Okay.
let's
All right.
focus here.
Okay. One more example, and then we're going to call it good for today. All right. That's right. Okay. All right. So, again, guys, I'm using some like funky different ones just to kind of be fun. All right. So we're going to do IR3 parentheses PO4 parentheses 2. IR3 parentheses. Okay, guys. Hey, remember I'm trying to record this, so yeah. Okay. All right, so let's start off with our first question. Does it start with hydrogen? No. What kind of compounds start with hydrogen? Acid. Yeah, we learned that on Friday. All right. So is the first part a positive ion or a metal? Yeah, it's in the middle, right? IR, iridium. Okay. Do we know the charge for iridium? No, it's in the middle and it's not one of the few that we know. So we have to calculate it. So how would I write the little algebraic formula? Wait a minute. 3x. Yeah, there you go. That's okay. Plus, this is where it gets tricky. It would be 2. Very good. All right, because we've got a polyatomic ion, we take the number that's outside the polyatomic ion. All right? So 2 times the charge for the polyatomic ion. So we look up PO4. What's its charge? Negative what? Negative 3. Good job. And what's the whole thing equal? 0, because the compound has to be neutral. All right? The whole thing has to be neutral. Okay? So, now we do our algebra, right? So 3x we bring down. And then what's 2 times negative 3? Negative 6 equals 0. Then how do we get plus 6 to a side? So add 6, add 6. So 3x equals 6. Now what? Divide by 3. X equals 2. So then we write the name with a Roman numeral. So iridium, Roman numeral 2. How do you do Roman numeral 2? 2 I's. And then we go back to our flow chart. All right? Is the negative mono or polyatomic? It's poly this time, PO4, right? So all we have to do is write the name of the polyatomic ion. So what's the name of PO4? Phosphate. Very good. All right, does that make sense? Is the flow chart easy enough to follow? Okay, let me stop our recording. Just a little over 15 minutes.